Hey guys, it's Raz. All right, part two. Let's talk about soil, the nitty gritty. Get it? So, a lot of this is going to be background information. I'll let you know, like some of this you're going to have to memorize, so you're going to have to know. Other things are sort of just for your information. So, I'll try to specify as we go through this. First of all, when we talk about dirt, it's soil, right? Soil is one of the most, I don't want to say undervalued, but kind of undervalued resources that we talk about in environmental science because most people don't realize its value, right? So when we talk about soil, we're talking about over to the right here, mix of geologic rock, organic components. There's different types of particles, right? Sand, silt, and clay. We're going to look at those really closely in our soil lab in class. We have humus, which is organic material that comes from, dead and decaying things that have been added. You got tons of nutrients, right? From phosphates to nitrates. You remember those with those cycles. There's water, there's air, there's living things in there. Like it is its own ecosystem and it is hugely important. Some of the reasons it's important are over here, right? We understand that obviously for plants, it's an anchor for their roots. That also is really important for runoff. If we have more plant growth, we tend to have less runoff. We keep a lot of that healthy soil where it needs to be. Water itself filters through the soil as it gets down into the groundwater. So it's like a natural Brita that's in our ground, which is pretty cool. Obviously, it's huge part of a lot of nutrient recycling, and it's a big habitat place. So it's one of those things that, again, we don't kind of take for granted, but it's hugely important. So a couple things. How does it get here? First of all, we start with weathering, right? Weathering is breaking down of rock into smaller pieces, and that can happen with a whole variety of ways, from physical things like wind and water to biologic things like a tree growing through it, right? To chemical. Acid rain will break it down. There's certain like lichens and moss that will grow on rocks that can actually break it down, things like that. The idea, they just keep getting broken down into smaller pieces. Erosion will then take that weathered rock and carry it to new locations and deposit it. It's called deposition, right? It puts it there. And soil formation is a process, right? It's a whole big thing. And it starts from that weathering of that parent material. Now, depending on the parent material, you're going to ultimately end up with different soil because there's different types of parent material, right? Determine things like you can see over to the right, soil pH. It's going to determine the nutrient content of that soil. We can also kind of see where soil settles based on the topography of the land. Places that have steep slopes, right, often have a lot of soil at the base there, like the bottom deposition, but not a whole lot on the slope itself because of runoff. And soil is going to form differently in different climates because I'm coming back over here now, because forming it also involves the breakdown of the organic matter through that soil. And that's going to be determined by the climate or affected by the climate. So warmer climates are going to have a faster breakdown. If there's more precipitation, there's also going to be more weathering and erosion. So that's the other side of it, right? And the organisms that are in there will also affect that soil formation, because if you have more worms and bacteria and fungi working to cycle those nutrients and break down that organic matter, you're going to have richer soil. Okay. Now, the soil horizons, this is one of those things that you are going to need to know. We're going to do a little lab in class where we build edible soil profiles to get you thinking about the properties of these. But basically, there's four major ones, O, A, B, C. If you can come up with a mnemonic to remember that, tell me, bonus points. I'd love to see what you can figure out. So that O layer, O horizon, is your organic material, right? That's where you're going to find all of the animal waste, the plant roots, the dead leaves, and it kind of sets on top of like the soil itself. It is hugely important for nutrients, and it also limits water loss to evaporation. It kind of keeps some of that water into the deeper layers of the soil. The next layer is A horizon. I call these all horizons, which I find like, I don't know, lovely. Anyways, A horizon is like your topsoil. So if you've ever done, reseeded a lawn or something along those lines and you've added topsoil, this is what you're actually adding. So it is a layer of humus, so decomposed organic matter and minerals. The most biological activity is in this A horizon because that's where a lot of those microbes are breaking down the organic material and they're releasing those nutrients. Okay. B horizon is below that. It is your subsoil. It's typically a lighter layer. Around here, like if you've ever done any gardening, you may notice when you dig deep enough, it kind of usually turns a reddish color around here. That's because of the mineral content of our soil in this area. But that's usually how you know you hit that B horizon. Like you can see the color change. I would tell you to go dig, but it's pretty frozen out there now. But when it gets warmer, go give it a try and see what you see. Anyways, it is mostly minerals, not a lot of organic material there. Again, there's some nutrients, but not a whole lot. It's typically just mineral mineral stuff. Below that is your C horizon. So that's your least weathered soil. It's what's closest to the parent material, and it's sometimes called bedrock. It can be like pretty solid. Again, it's most like the parent material. Okay, so one of the other things to kind of think about here is the idea of leaching. I showed you some of the horizons here, and you'll notice that there's a parent material at the bottom of this that I didn't have in my other one. But one of the things that can also happen is water carrying soluble substances. So like if I've got things that are dissolved in rain, for example, or they're small particles, those can kind of trickle through and they can affect that B horizon. Okay. It's actually really important because that's how we get a lot of salts and nutrients into the soil. And those are a huge, huge thing that, again, a lot of different living things rely on. They are a natural process of weathering. The problem is that sometimes they can build up in the top of the soil. And if we see it happen at the top, it prevents a lot of plant growth. Too much leaching, so if too much gets through there, it can actually remove nutrients from the top layers. Like it kind of like washes it down. And we end up with top layers of soil that aren't super conducive to plant growth. So it's something just to kind of keep in the back of your mind. I'm not going to go through this map. There's tons of different soil types around the world. You can kind of see they look fairly similar to the biomap. That happens, but I'll kind of leave that there. Do a little check for yourself here before you go on and hit pause if you need more time. The question is thinking of these three biomes, rainforest, desert, and a temperate deciduous forest. Which of those do you think has the most fertile soil to the least? Hit pause if you need a second. All right, so your answer, let's see how you did. Your answer is actually B, and this is usually surprising to most people. The problem with a tropical rainforest, the reason that it is not number one is that there is so much rain there that we actually get too much leaching of the nutrients in that environment. So temperate deciduous forest actually out of those three has the most fertile soil, followed by rainforest, followed by desert. Side note, I know that there's a little oops there. I hit the caps locks instead of the A and I haven't changed it in several years. So it's there. All right. So I'm going to go through this part pretty quickly because we're going to cover a lot of this in class. One of the things I want to make sure you know about soil texture, I'm sorry, I'm having a very difficult time here, is that there are three different types of materials. We've got sand, silt, and clay. Okay. Our soil is a mixture of those, and that's what we're going to kind of look at. Sand has larger particles, so typically we have more empty space between the particles there. You get more air and water that kind of come in. Clay, on the other hand, has the smallest, so that tends to be pretty, very few air pockets. Water doesn't really get in there much. So if you've ever been down south where they have a lot of clay and it's rained, you know that it doesn't like soak into the ground as much as we have here. So the particle size determines the porosity, which is the amount of pore space a soil has. More sand, more pore space, more porosity. More clay, less porosity. I'm still moving myself around. We use this little triangle that, again, we're going to have a ton of fun with in class to figure out the types of soil that we're looking at. Okay, what we aim for is loam. Loam is one of the best kind of soils to grow things in. But again, we'll talk about this in class. Skip through this for now. I'm trying to skip through it. It's just not working. There we go. So I mention this only because porosity and permeability and water holding capacity are going to have an effect on the soil fertility. Okay. Soil that's too permeable, that water goes through too quickly, like sand, isn't going to be good for plants because they're not going to be able to get that water. Clay heavy soil, it gets too waterlogged. They can actually suffocate. They can drown, basically. Plants can drown. So we aim for that kind of middle of the road, the sandy loam, which has a nice balance. And you can kind of read through what porosity, permeability are. Again, we're going to talk about this in class quite a bit. Okay. I'm skipping all this because we're talking about it in class. All right. So your FRQ, and you may want to, well, you can't wait. This is due on Friday. Never mind. I want you to describe one test that can be conducted on a soil sample and explain how the results could help you give advice to a farmer. If you're struggling with this one, do the best you can. I'm going to probably have you guys revisit this after we do the soil lab in class. All right. Happy writing. Talk soon. Bye.